Okay, so this last session is by three speakers, all of whom had NASA Center internships. And we will start with Kylie Halvorson.
Perfect. All right, I'm going to share my screen. And just everybody can see my screen. Just wanted to do a thumbs up or anything will be good.
Yes, we can see it. Go ahead.
Lovely. All right, well, let's get to it. Hello, everyone. My name is Kylie Halvorson, and I am excited to share with you my NASA internship experience at Johnson Space Center as a spacesuit engineer this last summer. So a little bit of an overview, I'd like to talk about my experiences in the apparel design major, including the wearable technology studio, some information about my perspective as a designer, focusing on my summer 22 projects, of course, with XEMU cycle testing and working with the soft goods lab at Johnson Space Center, specifically with some knee pads and a waist brief hip skirt. And also highlighting some intern lectures and overall analyzing designing for space in the future. I am currently a senior in the apparel design program in the College of Design. And my education focus so far has been a lot of sewing, pattern making, and research. I also had the opportunity to study abroad at the London College of Fashion in the fall of 2021. Just a little bit about me and some of my interests. I am involved on campus, and I've worked with social media and styling teams for Golden Magazine, which is a lifestyle and fashion magazine on campus. I love to travel and explore new places, and I enjoy spending time with my friends and family, trying new food, drinking coffee, and watching a lot of movies. The Martian is definitely a top 5 for me, so it was really fun to, really fun to see that and then work at NASA, I thought. So my NASA journey started when I took the Wearable Technology Studio course, and I was selected for a NASA project. And some of my classmates and I focused on textile design, production, and testing. My group mates and I created a non-electric pressure sensor as seen on the screen in front of you. The goal was to design and evaluate a low profile and non-electric mechanism to determine pressure levels applied to the back during spacesuit testing. The best route to evaluate pressure for our group was to create a textile using 3D printed points shown here at the bottom in gray, with varying grades of plastic using pigment and foam. The pressure sensor lies between the 2 layers of foam, which are indicated in the tan color, and the fluid containment layers, similarly constructed to bubble wrap, were constructed with an ultrasonic welder with different grades of plastic, shown in the yellow, red, and blue layers on the diagram. As pressure is applied to the points would puncture the layers of plastic and draining the pigment into the foam on the bottom layer. The colors correlated with specific grades of plastic, so the pigment indicates the amount of pressure applied to this textile. Once the pressure sensor is taken off the back, engineers are able to see the varying colors of pigment and align those colors with the levels of pressure. This project was a great opportunity to understand the connection between apparel design and spacesuit engineering. After completing the course and receiving an offer to work with the spacesuit engineers at NASA, I was a little bit intimidated. Having more of a design-focused background versus an engineering background did have me feeling a little bit nervous, but I think that the apparel design also provides a different perspective. And although my background may be different from those around me, I was able to contribute a new skill set. So with some reflection, I asked myself, how do experiences impact our design choices? So based on my education so far, 2 main areas of focus have emerged throughout my time at the University of Minnesota. 1 being historical context, and 2, visual communication with design. To be more specific with historical context, using design and engineering as somewhat of a historical time marker. Providing context allows designers to see progress and identify the innovations within various fields of study. And I continually ask myself, how will future generations differentiate between the past and the present? And that is where visual communication comes in. So visual communication provides the necessary visual tools to aid in understanding, using key markers to distinguish between the past and present. So for example, using color, shape, placement within designs to indicate this change. So, as many of you know, NASA loves acronyms. So, I decided to add another to my list and use it as a guideline throughout my internship, and I called it IPCR. So, IPCR standing for impact, or the I standing for impact, understanding the importance of each project and its contribution in furthering NASA mission goals. Preparation, maintaining organized and thoughtful procedures, progress, and development. Collaboration, working alongside and communicating between team members and branches to efficiently accomplish projects. Implementation, utilizing resources to move forward and take action. And reflection, identifying areas of improvement and seeking ways to apply new knowledge for the future. I applied all these concepts to three main areas of my internship last summer, which was XEMU cycle testing with spacesuits, working with the soft goods lab, and attending intern lectures from other departments, professionals, and companies connected to NASA. So to get a little bit and understand XEMU testing, XEMU, Exploratory Extravehicular Mobility Unit, cycle testing is the repetitive performance of activities that simulate the movements performed by astronauts in lunar environments to understand the life of the hardware that comprises the pressure garment system, or the PGS. To test the life of the suit, it is critical to utilize a brand new XEMU PGS suit at the start of testing to understand which components or design features are in need of redesign and or improvement as a result of the hardware failing prematurely throughout testing. Ultimately, the goal is to put the suit through as many movements and activities throughout the test series to analyze areas of success and areas in need of improvement for safe, efficient, and extended duration space exploration. The cycle testing results will provide engineers with a framework to improve and repair any anomalies within the XCMU PGS suit for future lunar environments and other NASA missions. Test preparation and clear communication were aspects that I approved upon each day. Understanding the scope of testing and the various jobs within the XEMU team provides the necessary context to fulfill my duties as an intern and as a testing engineer. Suit anatomy, terminology, and assembly were additional key tools for successfully tracking hardware connections and assessing the performance of the XEMU PGS suit. Clear, efficient, and organized data tracking procedures were implemented to quickly record data in a timely manner and optimize the number of circuits completed for each test subject. So one of my main roles was tracking data and movement outside of predetermined circuits and recording those hardware connections while testing the suits. So my overall impact was understanding the life of the hardware that comprises the PGS. As for preparation, organizing data sheets and tools like step trackers, hardware tallies, and circuit counting to provide accurate data and recording that efficiently. In terms of collaborations, being able to shadow engineers and technicians to learn about spacesuit anatomy, hardware, and components was very important and impactful. For implementation and action, measuring the progress of the circuits and uploading data in an accessible manner was also important. And as a reflection, this role really helped me reflect on how data contributes to the NASA mission and its history, both long-term and short-term. I also got to shadow and eventually lead as a testing conductor. That's me on the left with a cool headset and a hard hat and some cool glasses, which meant that I was leading the team and the suit subject through circuit activities and emulating astronaut lunar mission tasks. Like I said, I got to wear an awesome headset, which made me feel really cool. But this, I think, But yeah, this testing environment was really interesting because I got to go into the active response gravity offload system known as Argos, and Argos can simulate gravity on the moon and replicate this environment. So it felt very, very real in a sense for the astronauts who were testing. This area of my internship was very impactful in developing as a leader. As an impact, I understood the scope of testing engineers and the goals of data collection, making sure that repetition of movements to cycle hardware were consistent. As well as for preparation, planning a tentative circuit schedule, practicing circuit activities, and gathering necessary tools for the circuit to be completed. In terms of collaboration, I got to work closely alongside one of my mentors, Christine, and the testing team for a smooth, efficient testing process. And for implementation, I got to create my own circuit schedule for the day and again, develop and lead the team. As for reflection, utilizing technology within the suit to track each component automatically could be an area of exploration. But overall, I think organization and collaboration were the two biggest tools to accomplish a successful and safe testing experience. Now, for one of the second parts of my internship experience, I got to connect with a lot of individuals at the soft goods lab and utilize a sewing machine and apply some of my pattern making and sewing specs into these projects. And I think specifically for these knee pads that I got to construct, the impact was understanding the needs of each design to prevent any future anomalies for occurring. In terms of preparation, using time management of assembly and testing fabric components, and collaboration, again, working alongside other interns and engineers, and getting to implement all of these concepts and being able to sew was really exciting. I definitely am a hands-on learner, especially coming off of COVID and being able to be in person. I think this was absolutely one of the highlights of my internship experience. And overall reflection, the range of textile combinations and how they relate to the goals and performance needs, this was very impactful and strengthened my knowledge. And I would really like to strengthen this area in the future going forward. So these are the pair of knee pads another intern and I worked on for a different testing series during the summer. There were many layers of fabric, which was challenging to work with, but it helped me strengthen my sewing skills and again, knowledge of the fabric's behavior to be a better designer. One of the more independent projects I worked on during my internship was designing a waist brief hip skirt attachment to prevent and examine areas of abrasion. The impact being preventing future damage from occurring on the water connector inside the suit. And preparation was examining the waist brief hip area and its abrasion, located more on the front and right waist areas, and understanding how that area connects with other systems within the spacesuit. Collaboration, again, soft goods lab and engineers working closely with them, and implementation, prototyping, and sewing. I went through about 2 to 3 iterations, but this image right in front of us is the final product. And some reflection, I think problem solving when new anomalies impact the final product on, I think can be yeah, basically just like troubleshooting. I know on the right, I have some sketches and notes regarding the initial design and some specifications, but this, after connecting with other mentors and people within my field, I was really able to improve some of the design features and again, just troubleshoot any design errors that may have come about while actually creating the final garment. So this project was very technical in terms of sewing, construction, and examining quality, looking at the stitch length and making sure that's consistent, the seam allowance, and what was needed to make sure the product could withstand use and interact with the suit efficiently as well as the body for any future testing. And here are some fun images in the soft goods lab. Starting off on the left, I got to apply some patches for some spacesuits. In the middle, this was part of the knee pad assembly process and looking at different layers of fabric. And there's a really cool machine on your right that crisply pressed seams. It was like the coolest thing ever. I wanted to take it home, but obviously I couldn't, but it was still really exciting to be able to use that technology. So an intern lecture that stood out to me during my time at Johnson Space Center was learning about the opportunities and advancements of commercial spaceflight. more of a focus shifting towards fashion and function within this sector, specifically looking at engagement with the public media as well. I was able to have an informational interview with one of the social media leads at NASA, and they provided some great insight on how they utilize social media as a tool for astronauts to connect with the public when they're on missions. So, since I last made the slide, it's been about 7 months since I completed my internship, but it is exciting because many of these future plans are now just around the corner or have been completed. So I will be graduating this spring, which is very exciting. And I was able to implement research and some technology development into my senior thesis project in the apparel design program. I am still connected with Golden Magazine, but more in a styling role. And I also completed a fashion show, which was a large focus of my fall semester where I got to present this senior thesis. But I think one of my most prominent predictions I have been examining and still doing so today is the use of technology within garments, but how it is specifically applied to future commercial space endeavors. I foresee more creative and engineering fields merging together to create some groundbreaking work. So the next few pictures I like to call the Houston highlights. Another fellow intern from the apparel design program, Bridget, on your left. She and I got to work closely with each other on the knee pads project and just some other odds and ends. In the middle, just overall a great experience working with spacesuits and taking some cool pictures. That was really fun to take a disposable camera with me on and I also had some great barbecue. Houston has some really, really good food down there. So I definitely recommend checking some of that out if you ever have the chance to go. And these slides just traveling to nearby towns and exploring more areas of Texas. One thing I would like to highlight on the bottom right corner down here is I got to go to Mission Control and see some live space footage from the International Space Station, which I thought was a really, really cool opportunity. So a special thank you to my mentors who were able to guide and nurture my education, and a huge, huge thank you to the Minnesota Space Consortium for providing me with the resources to further my design career. Thank you all so much for listening, and I would love to answer any questions you may have.
So questions, I'll relay them to her. Go ahead, Kylie.
What are the polymers and fabrics used in knee pads?
Were you able to hear that question?
Yeah, so because of some of the sensitive natures of the testing and some of the they kind of kept some of those details under lock and key. So I'm actually not able to share specifics. I think there's a little bit of red tape in that area. I do know that neoprene that was one fabric that I got to work with at the University of Minnesota, and I did see that cross over at my time at Johnson Space Center. But some of those specifics, I don't dare tread into that area. I think I need some more clearance on that one.
Turned out actually that one of the other people we asked to speak at the symposium basically turned us down because we couldn't get permission to talk to them. So,
Yeah.
Other questions? Go ahead, Ben.
I'm just wondering, could somebody need to build like a simple wearable, like a step factor, and then somebody needs to balance kind of,
I think I'm getting a little bit of feedback. I don't think I heard that entire question.
Not sure. Let's see.
Oh. I was muted. I don't know what unmuted it.
Go ahead, Ben. Could you repeat the question? I didn't hear it either.
I was just wondering if it would be possible for, the average set of undergrad college students to build a simple wearable device like a step tracker. Would that make sense as an intercollegiate challenge, or is that perhaps more sophisticated than or just different? It just seems like there could be all kinds of cool projects that people across space could do that have to do with wearables.
Yeah, so I just want to make sure you said step tracker, correct? Correct.
It seemed like something that was tangible.
We actually talked about this. So it's funny because when I Yeah, when I was recording my steps, I literally had one of those like, yeah, a step tracker, and I just literally like for 8 hours, I just like track steps, and it it flew by more than I thought, but I think it would be interesting, especially when you put analyze pressure with that, because I think in the first couple days of texting, we had to kind of figure out, okay, what's just like a tap on the floor versus like an actual step that an astronaut is making, because or a test subject is using, because there'll be times when someone's just kind of floating and rotating. I think a step tracker would be very interesting, especially in relationship to the boot, or just looking at the floor as well. That is something that we kind of like ideated and talked through a little bit. So I think that would be a great challenge for students. And you said undergrad?
Yeah.
Yeah, I think that I think that's totally applicable. Yeah, absolutely.
It's funny to think of what it means to take steps if you're floating around.
Yeah. Well, because it was honestly, so thankfully there were two of us interns. So I wanted to be really meticulous. I was like, you can't let a step go by. This is NASA. But it was actually like some of the smaller steps, they were like, oh no, don't do that. Because at the end of the day, I compared my data with somebody else's, and they were like, whoa, how do you have twice as many steps as I do? I was like, I don't know. I just counted. So that was also a cool communication point, and just understanding like what exactly testing engineers are looking for. And yeah, it was a cool learning curve.
Okay, I think we're going to go on to our next presentation, but let's give Kylie another round of applause.
Yeah, thank you all so much.